Good morning. We are beginning semester 2 today, and welcome to that. And we're going to be covering in our unit 7, factoring, solving, and graphing cubic polynomials. And so cubic polynomials involve polynomials that have a leading degree in the leading term of 3. So x to the 3 is usually what you think about when you're thinking about cubics. And this video is going to support a worksheet that we're going to be doing, which is on GCF, Greatest Common Factor, Factoring and Graphing. And remember that you must also write notes, and you're going to put your first and last name on those notes, the date, the period, and the lesson notes, name and number. And if you're going to email it to me, you will also put it on the email header, that same information. And you're going to send it to me so that you'll get full credit for participation in your notes score. You're going to take notes on the video and upload them to me in the Student View Dropbox, or as I said, you could email them to me. And it would be by 11:59 p.m. Saturday. All right, so we're going to start out by factoring and solving this particular polynomial. Now you'll notice it has a leading degree of 3. And I'm going to enlarge this a little bit. I think that will help us somewhat, so let me do that. Let's just take a look at the problem down here. So we want to factor and solve this polynomial that has a leading degree of 3. And you're going to find doing this that we cover the same kinds of things that we were doing at the end of semester 2. We're going to start out with, first of all, looking at this. What can we factor out? Well, we can factor out the greatest common factor. So the first thing we want to do is the greatest common factor. Okay? And how do we do that? Well, we do it by dividing out whatever the greatest common factor is. Okay? And what are we going to factor out of this? We'll look at each term. It looks like we have an x in each one, so we can factor that out. We also have a 3 here, and you can note that 3 can also be divided into negative 27. So we can factor out 3x. Okay? And so once we've done that, then what we're going to do is we're going to go through the process of doing double bubbling. So double bubble. In other words, we're going to break the binomial here into 2 separate binomials. But let's start out by division. Let's divide out the greatest common factor. So we're going to divide out, we said 3x. So we're going to divide out 3x here, and we're going to divide out 3x here. Okay? And so when we do that, you know, obviously this cancels out. So let's just rewrite this. We're going to rewrite this because remember when we factor, we take what we're dividing out, the 3x, and we're going to put it over here on the left, and then we create a parentheses, and in the parentheses we're going to put what's left. So if we divide 3x out of 3x cubed, what are we left with? Well, we're just left with x squared. And if we divide 3x out of negative 27x, well, let's see. We can get out negative 9. Okay? The x's, you know, cancel out because x over x is 1, but negative 27 divided by 3 is negative 9. And so that's how we set this up. Now, this is equal to 0. And so, as I said, we want to double bubble next. So I've got to go ahead and try to factor x squared minus 9. So how do we do that? Well, we'll put the 3x over here on the left, and we're going to set up our double bubble, right? And let's look at x squared. How many, what times what equals x squared? And so that's x and x. So we end up with x as our first term in each of these bubbles. And then what times what equals -9? Well, there are a number of different things, but -9 here, 3 times -3. So +3 times -3 looks like that will give us -9. And that all equals 0 again. So that's the double bubble. Now, when you multiply this back together, if you need to, oops, I did this wrong. I start talking and I write things down incorrectly. So I have +3 and -3. So 3 times -3 does make -9, which is what we want. And x times x does make x squared. So now we have this set up. We have basically 3 terms now. We have this term here. We have this term in this bubble and this term in this bubble. And we want to use the zero product property now. And let me move this over just a bit so that you can see this better. Zero product property. And we're going to use that to go ahead and solve for 0, okay, because y equals 0. So we want to solve for the 0. So looking at this, we have 3x equals 0, right? We have, let's see, x plus 3 equals 0. And we have x minus 3 equals 0. Okay? All right. So we divide by 3, of course, here, and we get x equals 0. We would subtract 3 over here on each side, and we would get x equals -3. Right? And over here, we would add 3 to both sides, and we would get x equals +3. So those are our 3 answers that we would get on this. X equals 0, x equals -3, x equals 3. Okay? 3 solutions. So that's what we were doing. And I'm going to bring this back down. That's what we were doing when we were finishing up quadratics, only we were doing it on a quadratic level. Same process, same exact process for cubics. All you're doing is using the greatest common factor to get down to basically a quadratics level, and then you're just going through the typical factoring process to find out what x is when y equals 0. And that's it. That's pretty much what we're going to be doing today. But we're going to go on and we're going to actually graph that. So let's take a look at some examples here of what we're going to be doing. Now, so here we've got y equals x cubed plus x squared minus 6x. And we're going to find the zeros, okay, by factoring. So remember, the zeros here are your x-intercepts. All right? And then you're going to sketch the polynomial, and you're going to label the intercepts, and you're going to use a calculator to check. We're going to do that, at least at this time around, okay? All right, so again, we start out with x cubed here. And, by the way, if you want to use a calculator and you don't have, a TI calculator like I have, you can always use Desmos. So for a calculator here, you can also use Desmos.com. And they have a great calculator, as most of you know. If you have an issue, if you don't know how to get into Desmos, please see me. Just ask a question here during your Zoom meetings with me or on office hours, and we'll be happy to get you going with this. Okay, so I want to go ahead and I want to find the zeros. So that means I have to set y to 0. Y is going to equal 0. And so we're finding out what x is when y equals 0, and that happens to be your x-intercept. Okay? So we got 0 equals x cubed minus x squared. Is it minus or plus? Plus x squared, I'm sorry. Plus x squared minus 6x. Okay? And so what do we do first? We got to find the greatest common factor. So look to see, do we have GCF here? And well, there's an x that we can factor out of this. So let's go ahead and factor out the x. So we're going to do it this way. So we'll do 0 equals x times, now we take an x out, it's just the same as dividing by x here, divided by x here, divided by x here. So here you've got 3 minus 1, or x squared. Here this is x divided by x, so that just leaves us with 1x. Oh, this was x squared, pardon me. So x squared plus divided by x just leaves us with 1x, so plus x. And then you have negative 6x divided by x. The x is canceled because x over x is 1, so you have minus 6, or negative 6. All right, so now we're going to go ahead and factor this. Okay. All right, so what are we going to factor? Well, we already have the x factored out. The greatest common factor is out. Now we want to factor the trinomial, which is, again, using double bubble. Okay, so factor double bubble. All right, so let's write that. That would be 0 equals, and then we've got the x. Now, we're going to come up with two binomials. X times x is x squared, so we'll put an x in the first term of each binomial. And then we want to find two numbers that, when multiplied together, equal negative 6, that when added together equal 1. Well, you know, we can go through the old-fashioned way of doing it. We could do negative 6 times negative 1. We could do, let's see, negative 1 times 6. That's negative 6 times positive 1. Negative 1 times 6. We could do negative 2. Let's see here. Negative 2 times 3 equals 6, right? Or we could do negative 3 times 2. Now, I'm looking at this. All of these equal negative 6 if multiplied together, but when added together would equal, well, let's see, this one here, negative 6 plus 1 is negative 5. Negative 1 plus 6 is positive 5. We want a 1. Negative 2 times negative 3 is negative 6. But when added together, you get positive 1. So this is the one we want. Okay? All right. So knowing that now, we're going to write this out as x minus 2 and x plus 3. All right. So now we have our three terms. So these we can all set to 0. So x equals 0. Okay. Then we can have x minus 2 equals 0. And we can have x plus 3 equals 0. All right. So this one, x equals 0, that's fine. We already know what it is. This is the answer for the first 0. So that means when x is 0, y is 0. X minus 2 equals 0, well, all we really need to do is add 2 to both sides. So this is really x equals 2, right? Now I'm just doing a shortcut. You can do this shortcut too, because you can see that you would add 2 to both sides. So x equals 2, and so that's the next answer. And then the last one, we would subtract 3 from both sides, and so we get x equals 3. I'm sorry, subtract 3 is x equals negative 3. All right. So, you now know what x is when y equals 0. So this is, 0, 0, xy. This is 2, 0, xy. This is negative 3, 0, xy. So now we can go ahead and graph this. So I'm just going to draw a simple xy chart. Right? And we know that we've got one solution is at 0, 0, so that's got to be right here at 0, 0. And we've got one solution at negative 3. So negative 3 is somewhere over here. Okay. Notice I'm not going to really worry about this. I'm just going to put a point over here. So this is where x is negative 3. This is where x is 0. And then x is 2. I don't know, it's somewhere around here, right? So this is x is 2. All right, so we found 0, 2, and negative 3, right? Now, we want to know which way to graph these. So what we do is we look to the leading term in our original polynomial. And this is kind of like a linear equation. If the leading term is positive with a linear equation, then we know that our graph is going to go up. Okay? So that means we start down, somewhere down here, right? And we're going to end up somewhere up here. So what we're going to do is we're going to draw a line that goes like this, through this, and up like this. And so you'll see this is the down, this is the up. There you go. And so this is sufficient, ladies and gentlemen. This is all you really need to go ahead and sketch the polynomial and sketch the graph. Okay. So sketch the polynomial, and that's graph. Right? So you just graphed it. You've got that done. All right. Now, in using a calculator to check this, well, let's see, where'd my calculator go? I haven't had it around here somewhere. Here it is. So if we want to check it using a calculator, what we're going to do, turn this silly thing on, and then we're going to go up to the y equals button, click that, and we're just going to go ahead and type in the trinomial. Now, because y is going to equal 0, then we're going to assume that that's what this is, y is 0. So let's, we want to type in x cubed. So I'm going to go up here to my x button, and then I'm going to go down to the little caret here so that I can type in a 3 for x cubed. Then I'm going to add x squared to it, so I'm going to add, and then I'm going to go back up to the x button here, and then down here to where the x squared button is. If you see that right here, it's the second button, so I'm going to have to click. Oops, did I do that right? No, I went the wrong one. So let's redo that. I'm going to have to start again. So again, let's do x cubed. So I'm going to go up here to x, and I'm going to hit the caret button, and then I'm going to hit the 3 for cubed, plus, and then we said x squared. So I'm going to hit the x button again up here, and then here's the x squared button. So I'm going to hit that, and I get x squared. Now, I could have put caret 2 up there if I wanted to. I could have done that. You've got choices when you're doing the calculators. And then I want to have minus 6x. So minus 6 and then x again. Okay, so I now have it typed here. So what I'm going to do is go over to my graph. And there you go. It has the graph. So it's you can see, even though it's scrunched together because of the fact that we've got different scaling, it's just as you see here. It starts down here at the bottom, right? Starts down here at the bottom and ends up here at the top. So we know that we've done this correctly. Okay? All right. Let's go on and do the next one here. So we have negative 2x cubed plus 32x. All right. So again, we want to do a GCF on this. And we need to set this up as y equals. So I'm going to do that, y equals, and then I'm going to make it y equals 0. Okay. Make this a little bit bigger. So y equals. So I'm going to make it as 0 equals negative 2x cubed plus 32x. And I'm going to find the GCF. I'm going to factor out the GCF, the greatest common factor. So I've got a negative 2 here, and an x, and I got a 32 and an x here. Now, the negative 2 can divide into both of these two numbers, so I can take out a negative 2, and I definitely want to take out a negative, always in the first term. You always want to do that. So we're going to remove that, and we're also going to factor out an x because there's an x in each one of these. So that the GCF then will be negative 2x. All right? So let's divide by negative 2 for each of these terms, and you get 0 equals, and then we're going to, since we're factoring it out, negative 2x, I'm going to put the negative 2x over here, and then in parentheses I'm going to put in here x squared. And let's see, 32 divided by negative 2, that's negative 16, isn't it? And then, of course, the x, and this is, oh, and I'm also dividing by x. Okay, so let me make this clear. We're dividing out by negative 2x. I left out the x there, so I've just added it back in. So I got negative 2x cubed divided by negative 2x here. That, when you divide it out, leaves you with x squared. And then I have 32x divided by negative 2x. And when you divide all that out, you end up with negative 16. And this x obviously canceled. 32 divided by negative 2 is negative 16. All right. So now we got this correct. So we're going to go ahead and do our double bubble factoring, right? So I want to set it up like this. So let's just do that, and so I've got 0 equals negative 2x times, let's do the double bubble, and x times x is x squared. Now, what times what equals negative 16? That when added together, well, let's see. Leaves us, we've got a binomial here, so that's kind of interesting. Well, let's think about this a second. This is a square, right? And isn't 16 a square? So let's use 4 and 4. Now, if I use positive 4, though, I end up with a positive 16. I have a negative 16, so I have to use positive and negative 4. So I'm going to do positive 4 and negative 4. So this is actually what we call a difference of squares, because what happens is the reason why you don't end up with a trinomial when you get back up to the binomial x squared minus 16 is you have negative 4 times x plus 4 times x, and those cancel out. And so then that leaves you with the third term, which is 4 times negative 4, which is negative 16. So we've got that correct. We know we are in a good spot. So let's just go ahead and set these three terms, negative 2x, the x plus 4, and the x minus 4, let's set them all equal to 0. So negative 2x equals 0, x plus 4 equals 0, and x minus 4 equals 0. All right? So we divide by negative 2, and when we continue on through this, and we end up with x equals 0. So let's just simplify this as x equals 0. Right? And over here, we're going to subtract 4 from both sides. And so when we do that, we're going to have x equals negative 4. And then over here, we have to add 4 to both sides. So we're going to end up with x equals positive 4. Okay. So we now have our three solutions. We're going to go ahead and graph again like we did before. And we got one solution at 0. Okay. We got one solution at negative 4. We'll just put it over here. Doesn't really matter exactly where we get it, but we know that we need it there. And then 1 positive 4. So we're going to make these sort of equidistant if we can from the 0. Positive 4, negative 4. Okay. Now, does my graph start down and go up? Or does it start it up and go down? Well, to find that out, we always look at the leading term. And before here, the leading term was x cubed. That was positive. And so that's why in A, the graph goes up. Here, the leading term starts out negative. So you remember, if you have a negative linear function, meaning that the term, it will mean that the leading term is negative, then your graph is going down. Okay? And so since it's going down, that means we've got to start up and we've got to end up down. Down for here, we started down and we went up. So start up means we're going to do this, and then we're going to go down. Okay? And so that's what our graph is going to look like. Check it. We're going to go ahead and once more, let's clear this. We're going to type in y equals negative 2x cubed. So I'm going to do negative 2x. Oh, let's clear that. Let's do negative. Always remember, you start out with a negative sign down here at the bottom. This negative sign here. And you'll notice that the little negative sign is smaller. So negative, and that's because we're doing a negative, again, in the leading term, not an operational addition or subtraction. Okay, so negative, and it's 2x cubed. So 2, and then up here to x, and then we'll use our caret to type in the 3 afterwards. So that's negative 2x cubed, and then plus 32x. So plus 32x, and then we're going to go up here and we're going to click the graph button. Ooh, now that is off the charts. So I am going to have to go ahead and I'm going to have to change the window on this so that I can go ahead and be able to see. I'm going to have to scrunch down the y value. I'm going to have to make the y minimum maximum something less. So let's go over here to the window screen. And so here's the y minimum. Let's scroll down. The y minimum is now at negative 10. And looking at this, I'm going to use negative, well, let's try negative 20 and see what happens. Negative 20, and then the max we're going to make positive 20. So we're down 1, and so we're going to do 20. And let's hit graph. Well, it's better, but it's still not quite where we want it. So let's go back into the window. Let's try negative 30. So go down to the y minimum. We'll do negative 30. And the y maximum, we're going to try positive 30. And hit the graph again. Almost there, almost there. So let's go to 50. Let's go to negative and positive 50. So go back to the window. And so this is how you feel through this to make sure you can see the screen the way you want it. So I'm kind of demonstrating that. So negative 50 instead of negative 30, and positive 50 instead of 30. And now let's hit the graph. Now we can see it. And does it look like what we got here? Well, as close as it can, because again, what we're trying to do is we're trying to show that we're starting here at positive, and roughly speaking, where the zeros are. And so don't worry about the fact that your drawing may not look exactly like this. It's got to be just a reasonable representation of it to be a sketch, and you're fine. You're perfect. Okay. All right. So we're almost done with this. We've got 2 more to go, and we're going to do the same thing. I'm going to go a little faster because I'm not going to use the calculator on this to check it. I think we've demonstrated how that works, and you should be able to do that too. So let me go over here to the C and D problems. Oops, let's do this here. All right, so same thing as we did before. What's the GCF? So the GCF here. Now let's see. I've got an x in every one of these, so we know we're going to have an x, and then they've got a -2 here, -10 here, -8 here. Well, we can divide a -2 out of this as well. So -2x is my greatest common factor that I can factor out of all of these terms. So I'm going to go ahead and do that. So I'm going to divide by -2x. And remember, you wanted to get the negative out always when you're doing this. And that's going to give you an accurate graph at the end. So leading term always should be positive once you got taken out the greatest common factor. So if I divide out -2, and of course this is going to be 0, you're going to have y equals, will be now 0 equals. And so dividing out -2x, I will be left here with, looks like an x squared, right? And then over here, -10 divided by -2 is -5. No, +5, isn't it? +5. +5, and then x squared divided by x is 5x. And then -8 divided by -2 is +4. And the x's cancel because x divided by x is 1. So now I have my trinomial. All right, so now I want to know what times what equals 4 that when added together equals 5. Well, let's see. 2 times 2 is 4, but when you add together 2 and 2, you get 4. You don't want that. So how about 1 and 1 times 4? 1 times 4 equals 4, right? But when added together, 1 plus 4 equals 5. Now let's do it this way so it doesn't look confusing. So 1 times 4 equals 4. 1 plus 4 equals 5. So that's what we want because the middle term here is 5x. So let's rewrite this now. 0 equals -2x times double bubble. X squared is x times x, so that goes in as the first term. And then I have x plus 1 and x plus 4. And it really doesn't matter which order you put it in. Right? And so now it's pretty simple. We go ahead and we set each of these 3 terms to equal 0. So -2x equals 0. X plus 1 equals 0. And x plus 4 equals 0. All right, so -2x equals 0, then x equals 0. Because if you divide -2 times 0, it's 0. So x equals 0. Here we'd be subtracting 1, so x equals -1. And here we'd be subtracting 4, so x equals -4. Right? So those are our 3 zeros, so-called zeros, which are really the x-intercepts, or what x is when y equals 0. So set up our graph here. We got x at 0 here. You got x at -1, so that's, I don't know, about here. And x is at -4, let's see, somewhere around here. Again, you don't have to be exact, right? Okay, so we've got the 3 zeros in. Now the question is, again, does my graph start up and go down or start down and go up? Well, leading term, negative. If it's negative, then the graph starts down. So it's going to so to go down, obviously my graph's got to look like this, okay? So if that's the case, I start up. Oh, I didn't do that very well, did I? Not always so good at drawing things as I'd like to be. So let's see here. Okay. All right. So not a very good drawing, but that's the drawing that you would do. Okay. We aren't going to go ahead and graph that one, but you can do that on your own if you wish. All right, so we've got one more to go. Now this one here is set up such that the leading term is not where it should be. So we need to set this into standard form. That means we need to put the x squared term first. So we're going to rewrite this as y equals negative 2x squared plus 50. Okay. All right. So now that we've done that, we want to do the GCF. And so let's see. Oh, and let's set this to 0 too. And so the GCF is, let's see, I can take out negative 2 out of both of these. Doesn't look like I can take out any x's because I don't have an x in the second term. So I'm going to use negative 2. Right? And so since that's the case, I'm going to divide both of these terms by negative 2. So that leaves me with negative 2 times x squared, because this cancels. And then 50 divided by negative 2 is negative 25. Wow, there's no cube in this, is there? Well, we can still do this. This is just review. This is quadratics again. This is what you were doing before. So we got a double bubble, right? So double bubble. So I want to do the double bubble. What times what equals negative 25 that when added together? Well, it's going to create a cancellation situation. So look at this. This is x squared. This is 25, ignoring the negative sign for a moment, or the subtraction sign. So these are perfect squares. This is difference of squares again, which is what we saw in the previous slide. So we just set this up as negative 0 equals negative 2 times, and then doing our double bubble, x plus 5 and x minus 5. Okay? Difference of squares. So when you multiply those back together, if you aren't sure, x times x is x squared, then you've got negative 5x and positive 5x. They add together, they cancel out, so you got no middle term. And 5 times negative 5 is the negative 25. So you can see that's valid. Now we just set these up again for solutions. We want x here is, this is negative 2. Well, wait a second now. X is negative 2 here. Is that true? Is that true? Over here we got a negative 2, but we're dividing it out and it ends up to be x equals 0. And that's certainly a variable thing, but x does not equal negative 2. Okay? In this situation. Let's think about what we should do with that in a moment. But here, this is x plus 5, right? X plus 5 equals 0. So let's rewrite this so it's going to look a little easier to understand. So over here, there is no x, right? There is no x. You got just 0 equals negative 2. So this can't be true. Over here, this is 0 equals Now, let's do it the other way around. Negative 2 equals 0. Well, that, as we said, isn't true. So I'm going to cross that out. Then we have x plus 5 equals 0, and then we have x minus 5 equals 0. All right. So this, of course, you would subtract 5, so you have x equals negative 5. Right? So that is a solution. And then this here, you're adding 5 to both sides, so you've got x equals 5. Okay? All right, so I only have 2 zeros. So if I only have 2 zeros, how would I graph this? Well, this is a quadratic problem. Remember, quadratic problems, you use a parabola. So either your parabola is going to go up or your parabola is going to go down. Right? That's what you're doing here. So since this is a quadratic problem, we're only going to have 2 solutions for what x is when y equals 0. One's at negative 5 and one's at 5. Negative 5, 5. Now, does the parabola go up or down? Well, your leading term, remember your leading term is actually negative 2x squared. It gets moved this way because you go to standard form. So you've got a negative sign in that, so that means then your parabola goes down, starts down, ends down. Okay? So that's it. That's all it is, ladies and gentlemen, and we are done with this. So I will let you go, and you have a wonderful day. Take care.